Now let's see how to make use of other rules. So we finished with rule number 1 and rule number 3. So let's go back to rule number 2. So what the rule says, Laplace transform of t power n is n factorial over s to the power n plus 1 from the second column. Now what n factorial stands for? It stands for, you start with n, keep reducing it by 1 and multiply it until you reach to 1. Like for 3 factorial, you will have 3 minus 1 is 2, 2 minus 1 is 1, and multiply all this term together gives you 6. Similarly, like 4 factorial, start with 4, 4 minus 1 3, 3 minus 1 2, 2 minus 1 1, and you reach here 4 times 3 12, 12 times 2 24. Okay, so you don't need to worry about calculating n factorial, because nowadays in the calculator you have direct function over there. You can just press it and that will give you the result. Now, how this result will work, how this rule will work. You need to identify the value of n, which is power of t, and replace it here and here in the bottom. So like for example, if you have Laplace transform of t power 2, so in this case n is 2, correct? So what you will get, 2 factorial divided by s to the power, replace n by 2 plus 1. We just use the rule, nothing else. So this gives you 2 factorial over s power 3. It's okay, you don't need to solve it further. You can stop here. Okay. Similarly, let's take another question. Say Laplace transform of t power 7. Rule says 7 factorial over s to the power 7 plus 1, which is 8. I am writing it directly because n is 7 here. And how do we got 8 here? Because 7 plus 1, which is 8. Now, what else is, if you have say Laplace transform of t, how you will find it? T means t to the power 1. So here n is 1. So this will give you 1 factorial over s square. Okay, next, Laplace transform of, suppose you get the combination of terms, say t power 3 divide t, division, then how you will work? Then you have to work in the same way as we worked for the exponential function, t power 3 divide by t. So you can cancel 1 t, so it becomes Laplace of t power 3 minus 1, that is Laplace of t power 2, and then yes, you can write it as 2 factorial over s to the power 3. Okay, so now we saw how to work with t power n. In the same way we can work with other function, rule number 4, 5, 6, 7 and 8. So if it is sine of at, we need to get the value of a and substitute it here in these two places. If you get the value of, for cos of at, get the value of a and substitute it at only one place. Now for sine hyperbolic at, get the value of a and substitute it at 2 places. Now for sine trigonometric and hyperbolic function, rules are almost same, it looks similar, but the difference is that here in sine, in the denominator you have s square minus a square, whereas for sine hyperbolic it is minus. Similarly for cos hyperbolic and cos, in the denominator it is plus for trigonometric function and minus for hyperbolic function. Okay, so these are the things that you need to pay attention. Similarly for direct delta function, if it is delta t minus a, like if it is minus a, you get e power minus as. nothing else. Sign is not changing here.